welcome back to my math YouTube channel. So today I'm back here with another example on using partial fraction decomposition to evaluate an integral of a rational function. So guys, so far I showed you three different types. Excuse me. So I showed you three different types, and one of my friends actually was looking at my examples, and he got back to me saying that, well, all the types that I showed you, the degree of the numerator was less than the degree of the denominator. So then we were able to use the partial fraction decomposition using the general forms that we discussed in type 1, type 2, and type 3. And then we were able to write the integrals. But then what happens? But what happens when the degree of the numerator either is same as the degree of the denominator, or the degree of the numerator is greater than the degree of the denominator? So guys, here I want to show you an example where the degrees of the numerator and the denominator are the same, and the idea that we're going to use for this particular example is the same thing that one would use if the degree of the numerator is actually greater than the degree of the denominator. Okay, so we cannot use any of the simpler methods or direct methods or substitution or other methods on this particular integral, or we cannot even use the partial fraction decomposition yet, because the degree of the numerator is equal to the degree of the denominator. So it's not just going to work. So what we need to do first is we need to try to simplify this or break it down so that the degree of the numerator is less than the degree of the denominator. Guys, one of the ways of doing that is to actually go back and use our long division process, which is something that you have seen in probably in middle schools. But again, since we don't use it very often, so we can forget it. So I'm quickly going to set up the long division, and then you can see how we can use that long division and rewrite it in the form that we get the degree of the numerator less than the degree of the denominator. Okay, so enough said. So let's guys get to work and try to use the long division. In this case, obviously the long division would be set up like this. I got 4x squared minus 7x minus 17, and I got to divide that by the 6x squared minus 11x minus 10. So guys, don't overthink this. We would do exactly same thing what we would do if there was just a 4 here and 6 out here, right? So our goal is to get rid of this first term, and then whatever happens to the other two terms, well, we don't really care. So to get a 4x squared here, all we have to do is we have to multiply 6 by a fraction or some number so that we get a 4. So the obvious choice here is to multiply by 4 over 6. Why? Because 6 and 6 will cross out and I will be left with just 4, and obviously I have an x squared, so I will still have an x squared. But wait a minute guys, 4 over 6 can still be simplified. 4 over 6, because both have a common factor of 2, so this is same as 2/3, right? So instead of writing 4, 6, we're going to simplify this and write 2/3. Now let us go ahead and multiply this and see what we get right here. Obviously the first term will be 6 times 12 over 3 is 4x squared, and we definitely want this to be 4x squared. That's how the long division process works. And then let us see what we get for the other two terms. Guys, then we're done with this. Then this negative 11 times 2, we're going to get a fraction. Guys, there's nothing we can do about it. We got to, if we are getting fractions, we got to keep writing them. And then minus, the last one is also a fraction. Negative 10 times 2 is negative 20 over 3. So now we have to try to subtract this, right? We know that process of long division, you subtract. So when you subtract, so this is minus, this sign changes to plus, this also changes to plus. So guys, this goes away. Then I have to simplify this guy, and I got to simplify this guy. So let me show you how to simplify this. I mean, you already know how to simplify fractions, but I just wanted to still make sure that everybody can see how to really do it. So it's positive 22 over 3 minus 7, right? So to combine them, what I have to do is I have to think about this invisible 1 downstairs, then I have to multiply this by 3 upstairs and downstairs so that I get a common denominator. Once I have a common denominator, I can combine the numerators. So in this case, it's going to be 7 times 3 is 21. 22 minus 21 is just 1/3. So this is simply going to be 1/3 x, and then let us simplify this guy. So it's just 20 over 3 minus 17. Let us do it right here. 20 over 3, positive, because this sign is going to change to positive, right? And then minus 17. Obviously, we got to have a common denominator again. There is an invisible 1. Multiply by 3. Multiply by 3. Got 20 minus 17 times 3 is 51. So 20 minus 51 is negative 31 over 3. So it is negative 31 over 3. That is my remainder. Guys, this guy 2/3 is my quotient. So based on these quotient and remainder and the other two quantities, guys, we can rewrite this and I'm using the basic idea of the long division to rewrite this whole fraction. This is going to be same as integrating, guys. This is equivalent to 2/3, which is the quotient, 2/3 plus, and we put it in the parentheses. Then I have to write the remainder first, which is 1/3 x minus 31 over 3, and you got to divide this by the divisor, which is what you are dividing by, which is 6x squared. 6x squared minus 11x minus 10, and then there is of course a dx. So guys, please look at this term, these two terms now. 2/3 is just a simple constant, and we can easily find the integral of that because we know how to find the integrals of constant functions. We have direct formulas for that. And then guys, if I look at this guy right here, right away I can see that the degree of the numerator is less than the degree of the denominator, which is a good thing. Now it may qualify for type 1 or type 2 or type 3. All we need to see now is what happens, what is going on with the denominator in terms of the factors. Can we write this in the distinct linear factors or the factors repeating, or we cannot just factor it, it's just a quadratic, but we know how to deal with all those three types. So guys, the first essential goal is accomplished, that there was the degrees were the same, so we're now able to break it down so that the degree of the numerator is less than the degree of the denominator. Okay, now guys, if you are wondering how I was able to write it like this, again, let me quickly illustrate or show you a simple example with what you call just the numbers, and then probably from there you can easily kind of recall how we can and why we write it like this. So guys, just think about I'm just thinking about any two numbers. Let's say I have a 6 and I'm dividing by 4. Okay, so what goes 4 times 1 is 4, and then I have a remainder 2. So this is my remainder, this is my quotient. So guys, if I have to write this 6 over 4, if I have to write this ratio as the sum of two things, then based on what I got here for quotient and remainder, I can write this as the quotient 1 plus the remainder 2 over the divisor 4. Guys, that is how we usually write it. Okay, and if let us verify if this is actually correct, and that's exactly what we did here. This was my quotient. Okay, this was my quotient, this guy was my remainder, and this is what I was dividing by. Okay, and same thing here, the quotient, the remainder, and I'm dividing by 4. But let us verify if this actually adds up to 6/4. So there's an invisible 1, you multiply by 4, multiply by 4, 4 times 1 is 4, 4 plus 2 is 6, so it is actually the same thing as the left hand side. So this actually works, guys. Okay, so sometimes if I forget those simple concepts from middle school or even algebra skills, then I will go back and I will just try to look at the most basic thing. In this case, the most basic thing would be to looking at the how we divide just simple numbers. So from there I can see that I can write this ratio as the sum of the quotient plus the remainder over the divisor. Okay, guys, that's how I was able to break this down. So once we have it in this form, now let us go ahead and try to see how we can, 2/3 is easy, we can find the integral for that. Let's see how we can deal with this guy. So I'm going to need more room for that. So one of the things that I'm going to do here is let me break it down into two pieces. So it's 2/3 x dx. And then guys, here, again, it's up to you whether you want to do like that. I don't really like to work with the fractions unless we have to. So what I'm going to do is, guys, I can already take out 1/3 because 1/3 is going to be a common factor here. So I can already take that outside, and if I take it outside, then upstairs I will be only left with x minus 31, and downstairs I have this 6x squared minus 11x minus 10. So I'm going to just write it like that. And then there's a dx. Because guys, this numerator can be just written as x minus 31 over 3 because they have the same denominator, and I can just take out that 1/3, which anyway I have to do because it's a constant, and then I'll be left with this x minus 31 and then divide by this denominator and dx. Now, how does that help me? It just helps me that now I don't have to worry about this 1/3 or these ratios. Rather, I just focus on this particular rational function. Okay, sometimes that might just avoid some time and be more easier for us to work with this rational function. Okay, so on the side, guys, this is how we break it. We know we can already figure out the integral for this, but for this, again, just by looking at this directly, there's no easy or direct way of doing it. One has to try to use the idea of partial fractions. In order to do that, we'll try to factor this guy. But to factor this, guys, we know This is a quadratic polynomial. And again, if you have any direct ways of doing that as well on your own, feel free to do that on your own. But I like to use the basic concept of splitting the middle term. That's how I factor most of the quadratic polynomials. So how does that work? You multiply the 6 times 10. What do I get? I get a negative 60, right? And then I try to come up with two factors of negative 60 that add up to the middle term. That's why it's called splitting the middle term. So here in this case, what about negative 15 and 4? Negative 15 times 4 is negative 60, and when I add those two, I get a negative 11. So those work. So let us take it on the side. So it's x minus 31 divided by, and this guy, guys, I'm going to break this into, break the middle term into two pieces. And what are those two pieces? Negative 15x and positive 4x. So it is minus 15x, positive 4x, and then what do I have? I have negative 10 at the end, okay? So here what I'm trying to do is I'm just trying to find or write the factors for the denominator. Let us move on to the next step, x minus 31 divided by, from here we know we have to use the method of grouping. Whenever you have four terms in a quadratic polynomial, we try to use the method of grouping. In this case, let us see if we have a common factor here. The greatest common factor, in fact, here is going to be 3x. And then let us see what is left inside the parentheses. 3 times 2 is going to give me 6, so it's 2x minus 5. Yes, 3 times 5 is negative 15, and x there. Let us see what is the common factor, or greatest common factor here is 2. And then what is left inside? And I'm hoping that we are left with the same quantity. And in fact, this is 2x minus 5, because 2 times 2 is 4, and 2 times negative 5 is negative 10. So once we see that both these factors are alike, then we know we are on the right track. So we can now write the final factors for the denominator. And this is going to be 3x, well, there is a 2x minus 5 is one of the factors. And guys, what is the other one? The other one is going to be this 3x plus 2. So we have these two factors, and we can clearly now see that these factors in the denominator are distinct and they are linear. So it satisfies the first, it falls into the type 1 category, where we have the degree of the numerator less than the degree of the denominator, which is obviously true for this particular rational function. And the second criteria is that the denominator can be written as the product of distinct linear factors, and we can clearly see that these are two distinct linear factors. So now we know how to actually break these down or write the partial decomposition for this rational function. Let's go ahead and do that, and then we can find the integrals. Okay, so for that, let us see if we can, yeah, I may have to get rid of this. So get rid of this, and from here we take it up here. So I'm just still working with this piece, guys. I still have that other 2/3, which I'm going to bring in back at the end. And then this is 2x minus 5. And let us see what is my other factor, 3x plus 2. And this is, I'm going to break it into 2, a constant a over 2x minus 5. I like to be consistent because 2x minus 5 is my first factor, so I will start with that. And we already know that since I have only two distinct factors, I can break it down only into two partial fractions, a over this and b over the other one, 3x plus 2. From here, our goal is to evaluate or find the values for a and b. To get a and b, what we do is we multiply both sides by this denominator on the left-hand side, so that we can get rid of all the denominators and only work with just one equations. Okay, it's just simple linear equations. So let us see what we get. So when I multiply this to the left-hand side, I will be left with only x minus 31 on the left-hand side, right? Because everything will cross out. On the right-hand side, I will have a, and then what is going to be the other term multiplied to it? 2x minus 5 and 2x minus 5 will cross out. I will be left with only 3x plus 2. Then the next term will be b times, and in this case, the 3x plus 2 will cross out. I'll be left with 2x minus 5. Now from here, guys, you have different options to choose for x and then get the value for a and b. But what I'm going to do is I'm going to choose let x equals to, I'm going to choose x to be 5 halves, because when I choose x to be 5 halves, then this becomes 0, 0 times b is 0, 0 is gone, I can figure out the value for a. But you can choose any other values, and then you may have to deal with two different equations. Guys, it's up to you how you want to go from here, but my suggestion is always going to choose, like I would suggest choosing a value that isolates or eliminates one of the whole quantities, so that you can solve for the other one. Okay, so when I substitute x equal to 5 halves on the left hand side, so it is 5 halves minus 31 equals to, on the right hand side, this is a times, let us see what I'm left with here. 5 halves times 3 is 15 over 2 plus 2. I don't have to worry about this term because this is going to be 0 if I substitute x equals to 5 halves. Guys, we got to simplify this and then solve for a, which can be done because there's an invisible 1. You multiply by 2, multiply by 2. So it's 5 minus 31 times 2 is what? 62 over 2, right? And this is a times, let us combine these two. So 2 and 2 here, so 15 plus 4 is 19 over 2. Okay guys, I kind of did it quickly, but I'm sure you know how to combine fractions with just integers, okay? Let us simplify this further. From here, it implies, when I simplify this, it will be negative 57 over 2, and this will be a times 19 over 2, right? That's pretty simple here. Guys, I want a by itself, so what I can do is I can cross multiply, or I mean, you can already cross out these 2's. You can multiply both sides by 2 first to get rid of those 2's, and to get a by itself I have to divide by 19. So let us see, a equals to negative 57 over 19. Let's make sure the signs are right. Yeah, so this a is going to be, is this divisible by 19? 19 times 3. So it is a equals to negative 3. Okay, let me make sure that this is consistent with what I have here. A is negative 3. Yeah. So that, guys, is my value for A. Now I have to also find the value for B. Let's get some space so that we can write the value for B. So guys, here I'm going to get rid of this. So guys, focus on, let me box this. So guys, I'm just looking at this equation. Now to get the value for B, one of the ways is to just set x equals to negative 2/3 so that this whole term vanishes and I can get B by itself, and we can use that. Or in this case, what I'm going to do is I'm going to choose any other easier or simpler value for x so that I can solve for the other one. And my choice here is going to be x equal to 0, because if I use x equal to 0, I will not lose any of those terms, but I don't care if I don't lose both of them because I already have the value for one of the variables a. Okay, guys, I'm choosing x equal to 0. Again, you are free to choose whichever value you want to use, okay? So I'll choose let me see, I need another marker. Let me use x equal to 0. If I use x equal to 0, it will be 0 minus 31 is negative 31. On the right hand side, guys, 3 times 0 is 0. 0 plus 2 is 2, so it's 2 times what? 2 times I have a. So let me write that a first. Okay. And then there's plus b. And then let's see what is left inside the parentheses. 2 times 0 is 0. 0 minus 5 is negative 5. Okay. Let us simplify this. I already know what my a is. A is negative 3. So it is negative 31 equals to 2 times negative 3 is negative 6 minus 5b. If I add 6 to both sides, and then I'll get negative 25 is negative 5b. To get b by itself, I have to divide by negative 5. I get b equals to 5. Guys, I have my value for a, I have my value for b. Let us bring it all together and then try to evaluate the integral. So a and b is already known. Let us get back here. So I'm going to bring in that 2/3 as well. So this is equivalent to 2/3 dx, right? Then there was a plus integral of a, and now I have the value for that a, but oh sorry, don't forget there was a 1/3 because we already took that 1/3 out. And then there's an a which is negative 3 over 2x minus 5 dx. And then keep in mind there was a parentheses here. And then there's a plus b, which is 5, divided by 3x plus 2 and dx. And then I'm going to close this parentheses. Okay. I think we already have a, b, and all those rational functions. We can get rid of everything else, and now just focus on evaluating the integral of these 3 terms. Okay. Guys, this is pretty simple. 2/3, you just take that 2/3 outside. It's just integral of 1 dx, right? Nothing really special about that guy. Then plus 1/3 And let us already distribute that 1/3 with both these terms, because anyway we have to break them into two integrals. So when I multiply by 1/3, so it's going to look like this: negative 3 over 2x minus 5 dx, and then this is going to be plus 1/3 integral of 5 over 3x plus 2 dx. Right? I just distributed at 1/3. Now from here, let's see if we can simplify this whole thing. Guys, the integral of 1 dx is simply x. We know that. Just it's the integral of a constant with respect to x. So the first term will be just 2/3 x. For the second term, I'm going to take out that negative 3 outside. So it will just become negative 1. And then it's integral of 1 over 2x minus 5 dx. And then the last term, I will take out that 5 outside the integral sign. So it will be just 5/3 integral of 1 over 3x plus 2 with respect to dx. 2/3 x stays minus. Guys, this is an inverse function of the form 1 over ax plus b, and we know the integral of an inverse function is just the ln of the 2x minus 5. But don't forget, we have to still divide it by the derivative of the inner, or the coefficient of x, and the coefficient of x or the derivative of that inner in this case is going to be 2, so you got to divide that by that 2. And then the same thing with this third term as well. So it's 5/3. So let me write it down here, 5/3. And integral of this is going to be, again, it is an inverse function, so it is ln of 3x plus 2. Guys, I have covered these type of functions in detail in a section which I like to call as the shortcut of the form ax plus b of the linear form. So if you are not sure how I got that, please go back and look at that. But it is more like just using the direct formula for the inverse function, because it is an inverse function, and then dividing by the derivative of the inner. And it's only good, but it's only going to work if you are dealing with linear functions, and 2x minus 5 and 3x plus 2 are both linear functions. If I had quadratic functions, then I would not be able to write the integral this way. Okay, then we had to figure out some other methods and techniques. And this has to be divided by 3 as well. Let us simplify this a little further and write the final answer. So the final answer, guys, and I want to write the whole answer in just one line. So it's going to be the final answer from here. From here, I'm just writing it right here. So it is 2/3 x. That is my first term. My second term is going to be negative 1/2. I can write it like this: ln of 2x minus 5. And then my third term is 5 over 3 times 3 downstairs is 9. ln of 3x plus 2. And then, guys, there's a plus c because this is an indefinite integral. So, guys, I know there's a lot of steps and a lot of work, but this is the kind of problem that one has to actually do sometimes. And actually, I looked at this the textbook that I usually use to teach calculus 2, and I saw one of this particular example, so I decided to do this example. While I was actually working with this example, I realized there's a lot of fractions involved, so which is a good thing, because I want to show you some challenging problems as well, which involves fractions and which involves a lot of steps. So guys, with this example or examples of this type, my suggestion is that we have to be careful when we are doing these and check our steps and make sure we don't make any careless mistakes. So you have this example here as well now. Guys, in this case, the degrees were the same upstairs and downstairs, and we used the idea of the long division. Now, if the degree of the numerator is greater than the degree of the denominator, you would still use the idea of long division, break it down, and then try to find the partial fractions. And once you have the partial fractions, then you can mostly find the integrals. Okay, so guys, practice these problems. Again, you have any questions, please reach out to me through my comments or through my YouTube channel. I'll be happy to give you hints or actually work through those problems up here. Okay guys, good luck. I'll see you next time.